Have you ever looked at something really complex, like a jet engine or even your phone, and just wondered, how on earth does that go from an idea in someone's head to an actual thing I can hold? Well, today, we're going to pull back the curtain on a digital powerhouse that makes it all happen. Siemens NX. Let's find out how it works.
I mean, just look at this thing. It's this beautiful, complex dance of blades and curves. How do you make sure every single one of those parts is going to fit and work perfectly before you spend a dime on materials or manufacturing? That's the multi-million-dollar question, and it's right at the heart of modern engineering.
Because think about it, in today's world, companies are under this incredible pressure. They have to come up with better products, make them for less money, and get them out the door faster than everyone else. It's this super high-stakes race where being efficient isn't just a nice-to-have, it's literally everything.
And to win that race, engineers need some serious firepower. They rely on these incredible digital tools that let them simulate, test, and perfect a product in the virtual world before it's ever built. So let's dive in and see exactly how this digital magic works.
All right, first, let's really set the stage. To get why a tool like Siemens NX is so important, you have to understand the huge challenge it was built to solve. And that challenge is this collision point where insane complexity meets brutal competition.
You know, this might just look like a chunk of metal, but it's not. An arbor press is a super precise assembly of gears and levers and frames. Every single part has to be designed with near microscopic precision, so they all fit together and work. If just one tiny dimension is off, the whole machine could just fail. That's where things get really complex, really fast.
And all that complexity exists inside a total pressure cooker. This quote just nails it, right? It's not enough to make a great product anymore. You have to make it better, cheaper, and faster than your competitors. That's the hard business reality that's driving the need for these amazing digital tools.
And you can see how much the industry values these skills right here. On Coursera, a whopping 88% of people who took the Intro Siemens NX course gave it either a 4 or 5-star review. That's huge. It tells you just how critical this knowledge is for anyone who wants to solve these kinds of tough engineering problems.
So how do you even start to tackle all that complexity? Well, the journey begins with a digital blueprint. And for that, we enter the world of computer-aided design, or, as you probably know it, CAD.
Believe it or not, pretty much every sophisticated 3D part you can possibly imagine starts its life like this, as a simple, flat 2D sketch. Yeah, really, just lines and curves on a screen. This is the absolute foundation of everything that comes next. And the way you get from that flat sketch to a solid object is actually pretty logical. First, you sketch out the basic profile. Then, and this is the cool part, you use a command like extrude to basically pull that 2D shape into the third dimension, giving it depth. And finally, you start refining it, adding all the little details like cutting out holes or rounding the edges. And boom, here's that transformation in action. From those simple lines on the left to a solid, digital object on the right. This is that first giant leap, turning an idea in your head into a virtual part that you can actually see, spin around, and measure. Okay, so we've got our digital part. It looks great, but is it going to break under pressure? That's the big question, right? This is where we move into the world of virtual testing with computer-aided engineering, or CAE.
The core magic behind this is a technique called finite element analysis, FEA for short. The concept is actually brilliant. To figure out how a really complex shape is going to behave, the software breaks it down into thousands, sometimes millions, of tiny, simple pieces called elements. Then it calculates the forces on each individual piece to predict how the whole part will react to real-world stress.
And this is what that breakdown process, which is called meshing, actually looks like. On the left, you've got the clean, solid model, and on the right, that same model is covered in this web, this mesh of tiny little elements. That mesh is what lets the software do all its heavy-duty number crunching.
And this is the payoff. This color-coded map shows you exactly where the stress is highest. See those red areas? Those are the hot spots, the places that might crack or fail under pressure. This is so crucial because engineers can find these weak spots and fix them digitally, saving millions on physical prototypes and preventing real-world failures. We're talking safer cars, more reliable planes, and medical devices that work perfectly the first time.
Okay, so we've designed it, we've tested it, it's strong. Now, how do we actually make the thing? This brings us to the final piece of our digital puzzle, computer-aided manufacturing, or CAM.
You can think of NX's CAM module as a super smart translator.
It looks at the 3D model and creates a precise list of instructions for the big machines on the factory floor. This includes the exact path a cutting tool should take. It runs safety checks to make sure the machine doesn't accidentally damage the part. And finally, it spits out something called G-code. And that G-code, that's literally the language that these CNC machines speak.
And this quote right here connects our digital world directly to the physical factory. That G-code we just talked about, that's the spark. It's what kicks off the entire process on the shop floor, from planning the job all the way to holding that finished product in your hand.
So we've got design, which is CAD, we've got testing, which is CAE, and manufacturing, which is CAM. But in a lot of places, these are all separate worlds, which leads to mistakes and huge delays. The real magic of Siemens NX isn't just that it can do all these things, it's how it does them, all together as one seamless system.
And the secret sauce is this idea called the master model. What it means is that your design, your simulation, and your manufacturing plan all live in one single data file. There aren't different versions floating around in different departments. It's one file to rule them all.
So what does that get you in the real world? Oh, it's a total game changer. If a designer makes a tiny change to the model, the test simulation and the instructions for the factory machine can update automatically. This gets rid of a ton of rework and kills all those little errors that pop up when you're constantly sending files back and forth between different programs. It just works.
And this whole powerful integrated system is also really flexible. Companies can choose to run NX on their own servers if they want total control, or they can use a cloud-based version called NXX for more flexibility. It's all about giving them the power to pick the strategy that works best for them. And that really brings us to the final big thought here. When you create this single, unbroken digital thread that connects a simple sketch all the way to a finished part, you're not just making things a little faster. You're fundamentally speeding up innovation itself. It really makes you stop and think. With this level of power and integration, what incredible new ideas will we be able to bring to life next?